I just wanted to take a second and remind us of what we just talked about a moment ago, and that is, if I have an isosceles triangle where these two sides are equal to each other, and point M is the midpoint of the base, then this would equal that side. And of course, CM is equal to itself, and I end up quickly with these two triangles being congruent because of side, side, side equal to side, side, and side. And that means all their corresponding parts must be equal, and that means that this angle here and this angle here must equal each other. And since the two of them make a straight line, or half a circle, 180 degrees, each one of these must be 90 degrees, and that must be a right angle, and this one also must be a right angle. And it is said here in this particular case that CM is perpendicular to AB. In other words, it forms a right angle. And that's just to remind you that if I have an isosceles triangle and I have a line that runs from the vertex to the midpoint of the base, that it will form 90 degrees. Now what I hope to do is use that idea in order to be able to construct a perpendicular or create a right angle whenever I want to. And let's go over here and just get a construction line of some sort, say here. And I would like to cut that in half and make a 90-degree angle down there. Alright, let's get the trusty little compass out, and we'll swing an arc that is going to come up here and down here and over here and down here. So, and what I'm hoping is that when I draw the line segment across from here to here, that it will form 90 degrees in there, and I'd love to be able to prove that. Let's see what we can do with it. Oh dear, I just hit the camera. If you'll excuse me, I think we'll just keep on going. Alright, here we go. Let's draw from here to here, and from here to here, and from here to here, and from here to here, like so. And we will call this A, B, C, and D, and we'll call this one in the middle point X. Now I know that would be 90 degrees in there if I could know for sure that X is the midpoint of DB, but I don't know that for sure right now. It might be just an optical illusion. So I have to be able to come up with some way of more or less proving that it's true. What we have is that all these four sides are equal to each other. We have that. And I know that DB would equal itself by the reflexive property of equality. So I could talk about these two large triangles, ABD and CDB. Those two large triangles there. That would be possible. And if I were to do that, since I know these sides are equal, I think I could show rather quickly that this side over here must equal this side over here, and this side here must equal that side there, because all four of them are equal. And this side across the center here is equal to itself. So what I can show you fairly quickly is triangle DBA would be congruent to triangle BDC. DBA would be congruent to BDC. DC. Now if that's true, all their corresponding parts must be equal. This part right here, this angle here, and this angle here, they would be corresponding parts of these two triangles, so they would be equal to each other. Corresponding parts of congruent triangles are congruent. So angle 1 would be congruent to angle 2. Good. All right, let's see here now. How about this one? This angle here and this angle here are formed by intersecting lines, so they are vertical angles, and we know that vertical angles are congruent. We talked about that before. So I then would know this was because of corresponding parts of congruent triangles are congruent, and angle 3 would be congruent to angle 4 because they're vertical angles. And this side here is the same as that side there because we made them that way. That was given to us. All these sides are the same width. So that would give me an angle, and a side congruent to an angle, and a side. So I can now say triangle, what shall we call it? Shall we say X to D to C would be congruent to triangle X to B to A because of the angle side theorem that we did before. So those two triangles would be equal to each other. And since these two triangles are equal to each other, then the distance from here to here, from X to B, must match the distance from X to D because they are corresponding parts of congruent triangles. So DX must equal BX. They are corresponding parts of congruent triangles, and they're congruent. So their distances are equal, and that means that X is the midpoint. That meets the definition. X is the midpoint of line segment DB. Because that's what a midpoint is. It's where the distances are the same in both directions. So if that's the case, then, if you'll return back to what we had just a minute ago, if you have an isosceles triangle where a line is drawn from the vertex to the midpoint of the opposite side of the base, then these two turn out to be 90 degrees. So what I've done here is shown that if I were to swing arcs above and below a line and connect them, I would end up with a perpendicular line, and this in here must be 90 degrees. Angle 3 must be 90 degrees. And that's what we hope to show. If I ever want to draw a perpendicular line or make a 90-degree angle, that's a way I can do it.